Hello everyone! Our joke of the day is, what do you call a deer with no eyes? Stay tuned for the answer. Today our learning target is I can use scientific notation to rewrite big and small numbers. Another learning target we could use would be I can rewrite numbers from scientific notation into standard form, or I can rewrite numbers from standard form into scientific notation. Okay, so what's scientific notation? Well, it's a method to write a very large or very small number in an equivalent and cleaner form. That way you don't have to write out the whole big thing, and you'll see what I mean when we start getting into some of these examples. You might have seen these before, maybe in another class, like a science class, or maybe even on the news or in something like that. Okay, so let's look at some examples of numbers in scientific notation. So these numbers here are all in scientific notation. Well, what do we notice about them that is the same? Okay, let's look at this. They're all times 10 to some power. Okay, that part is all the same. It's times 10 to a certain power. Okay, well, let's see. What else might they have in common? Where's the decimal point in each of these numbers? Well, it looks like the decimal point always follows the first number. Okay, so there's a number in the ones place, right? And then a decimal point, and then there might be some other numbers after that. That will be important when we start rewriting these numbers. Okay, so let's rewrite the following numbers in scientific notation. Again, this is what scientific notation looks like. Well, how do we do this? First of all, we need to find where our decimal point is to start with. When we have this number, 201 million, we have the decimal point is at the end, right? If we don't see a decimal point, it's always just going to be after that last number. Okay, now let's count and see how many places we have to move the decimal point in order to get it right after the ones place. So we have 1, 2, 3, 4, 5, 6, 7, 8. Okay, so our new decimal point should be right there. So in scientific notation, it'll start with 2.01. Now we know it needs to be times 10 to some power. Well, that power is going to be the number of places we had to move that decimal point. And I counted 8. So our number in scientific notation is going to be 2.01 times 10 to the 8th. Okay, let's check that. So we want to try and rewrite this from scientific notation back into standard form. So we'll have our 2.01, right? And now we want to move the decimal to the right 8 places because it's a positive 8. So it means we have a really big number. So 1, 2, 3, 4, 5, 6, 7, 8. Put our decimal point there. We'll fill in these with zeros. One of those kind of looks like a 6. Let's fix that a little bit. There we go. And we get 201 million, just like we had before. Now what if we have a small number? Well, with this one, we're going to have to move the decimal place the other way in order to get it after that first number. That's not a 0. So I'll have 1, 2, 3, 4, 5. Okay, we put our decimal point there. So we get 5.1. We know it's times 10 to some power. Well, we moved our decimal point 5 places, but we moved it the opposite way this time, which means you have a really small number, right? So this is going to be 10 to the negative 5th. 5.1 times 10 to the negative 5th, because that would tell us now when we're rewriting it back in standard form that we want to move our decimal place to the left 5 places. So I'm going to start with my 5.1 over here, and we're going to go to the left. 1, 2, 3, 4, 5, and see if we get the same thing that we started with. Fill these in with zeros. And there's 1, 2, 3, 4 zeros in the first one, and 1, 2, 3, 4 zeros in this one. So there we go. We did it right. Okay, now we have 68,700,000,000. Let's rewrite this one. So our decimal point starts over here again. We go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Decimal point will go between the 6 and the 8. 6.87 times 10 to the 10th. Okay, we're not going to rewrite that one. You could rewrite it to check your work, but we did that for the first couple, so we'll just move on. Okay, now we have to move our decimal to the other side way. So 1, 2, 3, 4, 5, 6. And we end up with 7.25 times 10 to the negative 6. Okay, that's rewriting numbers from standard form into scientific notation. Standard form is the one that we're used to most of the time. Okay, now we're going to do the opposite. Rewrite from standard form into scientific notation. Okay, remember which way we have to move our decimals. Okay, so if we have 6.32 and we have 10 to the positive 9, that means we have to move our decimal to the right 10 places, or 9 places. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, it's going to be there. 1, 2, we'll fill in those zeros. Okay, now I'm going to rewrite it just because then we don't have all those little loops in there. So our answer for this one will be 6, 3, 2, 0, 0, 0, 0, 0, 0, 0, which looks like 6,320,000,000. Okay, now if we have the negative exponent, oh wait, let's look at this one. If we just have the 4, there's no decimal point there. We have to remember our decimal point is always going to go after that number, after that whole number. So we'll have 4, and here's our decimal. Now we have to move it to the, oh wait, here. Let me get this a little better so we can have a little more room, because we have to move our decimal to the left now. 1, 2, 3, 4, 5, 6, 7. Here it is. Fill in those with zeros. And there we go. We can rewrite it too. 1, 2, 3, 4, 5, 6 zeros and a 4. Okay. Now let's look at this next one. We have a positive 6, so we're going to move our decimal to the right. 1, 2, 3, 4, 5, 6. Okay. And then we'll have 3,201,000. Okay, last one here. Looks like we have a negative exponent, so we'll want to move our decimal to the left 5 places. 1, 2, 3, 4, 5. Fill those in with zeros. Rewrite it. And there we go. Now we also might use our calculator sometimes for these. And your calculator will display these images, and we have to figure out what they mean. Well, these are usually in scientific notation. Okay, so let's look at this first one, 1.5, and then you see that negative 10. Well, that really means 1.5 times 10 to the negative 10th. Okay, so if we were going to write this in scientific notation, it'd be 1.5 times 10 to the negative 10th. Okay, now we can write it in standard form from there. We have, I'll use a different color for this one, maybe green. 1.5, but then we have to the negative 10th, so we move it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 places to the left. And then put our decimal in there. Okay, we have 1, 2, yeah, let's move it. Fill those in with zeros. And there we go. This one looks much more similar, right, to our scientific notation from before. We have negative 8.12 times 10 to the 9th. That's already pretty much in scientific notation. We can just rewrite it, 0.12 times 10 to the 9th. And now we can rewrite that in standard form. We have a positive exponent here, so we're going to move to the right 9 places. 1, 2, 3, 4, 5, 6, 7, 8, 9. Fill that in with zeros. Okay, and we'll end up with a really big number. Looks like 8,120,000,000. Whoa, there you go. Okay, now you also might see this weird like E thing, and E7 means times 10 to the 7th power. The e is just another way to write that times 10, okay? So in scientific notation, this one will look like 7.21108 times 10 to the 7th. Okay, and it's a positive exponent, right? So we're going to move to the right. Negative 7.21108. 1, 2, 3, 4, 5, 6, 7 places. Okay, we could rewrite that one. Negative 7.21108. Negative 72,110,800. All right, I know you're all really anxious to hear, what do you call a deer with no eyes? No idea. Have a great day and thanks for watching.